Hello everyone. In this presentation, I will discuss the real-world applications of container technologies and some of the best practices developers should follow when working with containerized systems in the cloud. Container technologies have become a standard approach for building modern applications because they allow developers to package software into portable environments. In addition, AWS provides multiple services that simplify the deployment and management of containers including Amazon ECS, Amazon ECR, AWS Fargate, AWS Batch, and AWS Lightsail. In this presentation, I will explain how these technologies are used in real systems and what practices developers should follow to build reliable and scalable applications. So, let's dive in. Containers are widely used in modern software systems. Many organizations deploy web applications and APIs using containers because they provide consistent environments across development, testing, and production systems. One of the most common architectures used today is the microservices architecture. In this approach, a large application is divided into smaller services that run independently. Each service can run inside its own container, which makes it easier to update and scale individual components of the system without affecting the entire application. Containers are also play an important role in cloud architecture. Cloud platforms such as AWS allow containers to scale automatically depending on demand. For example, if a web application receives a large number of user requests, additional containers can be launched automatically to handle the workload. When demand decreases, some containers can be stopped to reduce costs. This dynamic scaling capability makes containers ideal for cloud environments. Containers are also widely used in DevOps workflows and CI/CD pipelines. CI/CD stands for continuous integration and continuous deployment. In these pipelines, developers automatically build, test, and deploy applications whenever new code changes are introduced. Containers ensure that the application runs in the same environment during deployment, testing, and production. This reduces errors and improves the reliability of software deployments. Another important use case for containers is large-scale data processing. AWS Batch allows organizations to run thousands of containerized jobs automatically. For example, companies can use AWS Batch for financial simulations, scientific research, machine learning model training, or large data analytics workloads. AWS Batch automatically manages job queues and compute resources, allowing developers to focus on their workloads instead of managing infrastructure. Several tools and services are commonly used to manage containerized applications. Docker is used to create container images and run containers locally. Amazon ECR provides a secure registry for storing container images. Amazon ECS is used to orchestrate and manage containers at scale. AWS Fargate allows developers to run containers without managing servers. Together, these tools create a complete environment for developing and deploying container-based applications. When working with containers, developers should follow several best practices. One important practice is using small and optimized container images. Smaller images reduce startup times and improve system efficiency. Another important practice is implementing strong security policies. Developers should regularly update dependencies, restrict access permissions, and use secure container registries. Finally, maintaining version control for container images allows organizations to manage updates and roll back to previous versions if necessary. In conclusion, container technologies have become essential for modern cloud deployment. Containers allow applications to run consistently across environments and scale efficiently based on demand. AWS provides several powerful services, including ECS, ECR, Fargate, AWS Batch, and Lightsail, that simplify container deployment and management. By combining these services with best practices such as monitoring, security, and optimized images, developers can build scalable and reliable applications in the cloud. So, thank you for watching and don't forget to follow me and leave a like.